Okay, in this lesson we are going to learn about conditional probability. Now, probability is a matter of trying to guess about something that might happen. And so I'm imagining that my buddy Greg came up to me and said, dude, guess what? My daughter just picked her extracurricular activity. Guess what it was? Now, there's a lot of extracurricular activities. Maybe she's joined the chess team or the drama club, and I'm supposed to guess, all right? So I have a certain probability of maybe guessing correctly depending on how many different extracurricular activities there are, all right? So that's just straight probability. But then imagine that Greg says, wait, let me give you some additional information. I'll tell you this. It's a sport. Now guess. Okay, so what just happened to my probability of guessing correctly which activity she chose? All right, well, now we've narrowed it down. Now I can just think about, well, what are the sports, the female sports at the school where she goes? The list just got a lot shorter. My probability is going to get better. So that's conditional probability, where you're trying to make a guess, but wait, let me give you some extra information first, and now you're going to make a better guess. That's conditional probability. And there's two ways to do it. If you're given a table, you can use the table to narrow down the universe, all right, to just what you're given, and forget about the rest. If you're not given a table, there's a formula that you can use. But we'll save that for the next lesson. Okay, so let's dive in. A random survey was taken to gather information about grade level and car ownership, status of students at a school. This table shows the results of the survey. Okay, so we have car ownership by grade. So in this row we have juniors, seniors, and then we got the totals. All right, so in this column we have owns a car, does not own a car, and then totals. So this 6 represents the number of juniors in the survey who owned a car. And apparently there are 10 juniors did not own a car. All right, notice that's a total of 16. Okay, so you get it. Now, find the probability that a randomly selected student will be a junior given that the student owns a car. Now look, if they had not said that last piece of information, that additional extra piece of information, okay, like let me cross this out for a second. If they had just said find the probability that a randomly chosen student will be a junior. Well, the way we do probability in general is we do target over total, and my pen is too big, but I'm deep into this problem right now. Target over total. Okay, so I need to know what's the total number of students in the survey. Well, luckily they helpfully gave me the total number right there. We had 16 juniors and we had 20 seniors. That's a total of 36 people. Okay, so target over total. Now, so what's the probability that we'll have a junior? Well, there's 16 juniors. So that would be 16 out of 36. So that's the probability that the student will be a junior. Okay, if I reduce that down, okay, that's 4/9. Let's go ahead and look at a percent. All right, so that would be 44.44%. Okay, so a little bit less than 50% chance, all right, of that it's going to be a junior. Now, but they gave us some additional information. They say given that the student owns a car. Okay, So we know that the student owns a car. So we can forget about everything else on the chart. Okay? Over here, this part where students who don't own a car and all that, that doesn't apply. Alright? Because guess what? The student owns a car. So we no longer care about this. So the universe has gone from 36 down to 18. Okay? Because we can forget about the ones who don't own a car. So if I want to know the probability now of being a junior, I can make a better guess, because now when I do my target over total, my target is still juniors, but now I'm only concerned about the 6 of them, okay, because I can forget about the ones who don't own a car. And so I'm still doing target over total. Target over total. But in the universe of students who own a car, there are 6 juniors out of a total of 18 students. Okay, so in that case, the probability, this reduces down to 1/3, which I know is 0.3 repeating, which is the same thing as 33.33%. I mean, we're rounding. Okay, so that is the answer to problem number 1. Alright, this is more accurate because I had the extra information. So basically, with conditional probability, you're given some additional information that allows you to throw out part of the sample space, and it narrows it down for you. Okay, so think of it that way when you have a table. Okay, I guess we're still dealing with the same chart, so let me not scroll away too far. Find the probability that a randomly selected student will own a car, okay, given that the student is a senior. Okay, so guess what? The student is a senior. That's a fact. So we are only going to look at this part of the chart. Alright, nothing else matters anymore. Okay, student is not a junior, so just cross that out. So we don't have to worry about totals that involve juniors. Alright, so again, the sample space, the universe, has just decreased from the original 36 to now we're down to a total of 20. So when we do target over total for our probability, we want the randomly selected student to own a car. Alright, so this is the target. Okay, so how many students own a car? 12. 12 students own a car in this narrowed down universe. Out of a total of how many students? Well, in this narrowed down universe, the total is 20. Okay, so this is going to reduce down to what? These are both divisible by 4, so that's 3/5. So that's what? 0.6, which is the same thing as 60%. Okay, so that extra information, given that the student is a senior, that narrows down your universe. And then you just go with that. So it's pretty easy when you have a table. Okay, the table below shows the numbers of registered voters by age in the United States in 2004 based on the census. Find each probability in decimal form. Okay, so we have these age ranges. Alright, so from 18 to 24, that age range, we had this many registered voters. Okay, in thousands, that means there were actually this many. Okay, this is how many thousands there were. But let's not worry about that right now. Basically, when they say in thousands, whatever answer you get, you could just put the word thousand on it. Feel it's coming on. I guess that wasn't much of a warning. Sorry about that. Anyways, so we have registered voters and those who are not registered to vote. Okay. So what are they asking us for? Find the probability that a randomly selected person is registered to vote. Now here comes the conditional part. Given that the person is between the ages of 18 and 24. Well, that's quite a gift. If they give us that the age is between 18 and 24, that means we can forget about the rest of the chart. We can just look at this part of the chart. The rest of the chart, we will throw it out. Hold on, let me really. Okay, so the person is not in that age range, not in that age range, and not in this age range. So we will just look at what we're given. We have narrowed down the universe to this row. So with that in mind, what do we have here? Okay, so what's the probability that the person is registered to vote? So again, target over total is how we do probability. Target over total. Well, the total in the narrowed down universe, well, you know what, we have to find it. Because what we have, we don't have totals given to us. We have registered voters and not registered voters. Those are the only two possibilities. So if we want the total, we could just add. Okay, so if I add these up, what do I get? So let's see, I'm taking my calculator and I'm doing, do you need to see me type it? 14,334. Can't you imagine it? Do you have no imagination? Alright, so we're adding. So I take that, move this aside, and I'm going to add the other one, 13,474. Okay, so there's my total is 27,808. Okay, so target over total, that's the total, 27,808. Now the target is registered to vote. Okay, so registered voters, that's your 14,334. Okay, so target over total. 14. Bring my calculator back. Okay, so as a decimal, I've got 0.5155. Got to round up. Alright, so we're rounding, so we've lost some accuracy, but so this is equivalent to 51.55%. So a little bit better than 50% chance. Okay, so pretty easy, right? Are you feeling how easy this is? Let's do another one. Find the probability that a randomly selected person is not registered to vote, given that they are 65 and over. Okay, love it when I'm given stuff. Doesn't everyone love a gift? Alright, so this is what we're given. When you're given something, you run with it. So we're given this. That means we can forget about the rest of the chart. Okay, forget about this, forget about that, forget about that. None of those are what's happening now. So I want probability. So I know I'm going to need target over total. So might as well get that total lined up. Alright, so we're just going to add these up for the total. Okay, 26,706 plus 8,033. Okay, there you go. That's not going to be visible when I touch this. 34,739. Okay, that's the total. So when I do my target over total, for a probability, I know my total is going to be right there. So 34,739. And my target is randomly selected person is not registered to vote. This is my target. So let's see, not registered to vote. So that's my target. So 8033. Okay, bring my calculator back. Yeah. So I've got 8033 divided by 34,739. Shazow. Okay, so we're going straight to decimal. 0.2312. Which as a percent would be 23.12%. Okay, easy peasy lemon squeezy. What's up? Find the probability that a randomly selected person is between the ages of 45 and 65 and is not registered to vote. Wait a minute. This problem's a little bit different. Alright, this time we're not being given anything. There's none of this magic. Given that they are this. Given that the person is that. We're not given anything. Okay? This is just a regular probability problem. So, we do not get to narrow down the universe this time. We are stuck. Oh, wait a minute. That's not the total. I'm used to this corner number being the total. We are going to have to deal with the total of the entire chart. So we're going to have to deal with that. Okay. We've already done a couple of totals, so let's put them on there. Let's see. When we dealt with the ages from 18 to 24, we found out that the total there, hold on, was 27,808. So, if you add up these two numbers, you got 27,808. When we were dealing with people over 65 and over, then we were dealing with this part of the chart. And if you added those up, we got 34,739. Alright, we need to know the total number of the whole universe so we can do a full probability. So we have to add these other numbers as well. So let's go ahead and add these numbers too. Okay, so in fact, I'm going to do that off camera and you'll trust me that I did it right. Okay, so I'm trying to find out the total number of people in the sample space here by adding up all these numbers. So far I've added up these, and here is what I have. So now I'm about to add up these numbers to get the overall total. Alright, so this is the total number of outcomes in the sample space. Alright, this is the total number of people recorded by the census. So when I do this probability, I'm going to do target over total, but this is going to be my total. Okay, now the target. Find the probability that a randomly selected person is between the ages of 45 and 65 and is not registered to vote. So we need to find that intersection. And look, it's right here, okay? Between the ages of 45 and 64. Okay, so that puts us in this row. And is not registered to vote. Okay, that puts us in this column. So that means this is the number of people that fit that description. Alright, they're in this age range and they're not registered to vote. So this is my target number. So target over total means we're going to do 19,355 out of the total number of people on the chart. Alright, and that is going to give us our probability. Okay, so there you go. Whoops, I didn't memorize it yet. 0.0897. By the way, always use 4 decimal places when you're writing the decimal form. That way, when you turn it to a percent, you still have 2 decimal places. So when I move this over, this becomes 8.97%. Alright, and that is the answer for number 5. And that's going to do it for this lesson. I hope it was helpful. Remember, if you're watching this video, you're one of the good ones.